All right, this is Chapter 5, Section 2. This is Part 2. So, the compound interest formula, right, has future value and present value. So if you think about the formula, right, the amount that you put in is the present value, right? So that is your present value, the principal, right? Present value is the principal. After a certain time period, right, you will have another amount in the account, which is the future value, the compounded event, right? So A is the future value, and the present value is P sub 0, the principal, correct? So future value is the maturity value, which is the compounded amount, right? So as you compound it over time, in the future you will have some value, which is the maturity value. The maturity value is the value at the end, right? The future value can be many values in between, essentially, right? So you have these little circles again, which are very nice. So if I do a bit of algebra, I'm going to get present value, or principal, right? This is P sub 0, equals the future value over 1 plus r. So essentially what's happening is I'm taking this equation and dividing by the interest part on both sides, right? Which will cancel and leave me with this formula here, okay? Which is what we figured out from the circle up here, that the principal equals this right here. So if I want to know the principal I need to deposit, this is the formula I would use, which is the same formula algebraically manipulated. Okay? So I'm going to copy that formula right here. Where did I have it? There it goes. I'm going to steal that formula. Copy and paste. Okay. So you need $40,000 from an 18-year, 6% investment compounded semi-annually. How much should you invest? So you're saying you have a kid that's just born, and you need $40,000 when they graduate high school for whatever, a new car, maybe if their books for college, who knows. How much do I need to put in right now to get $40,000 18 years from now? Okay, so the amount that I want, let's just do this like this. We'll do an equals, and we'll do this, right? So we need $40,000. That's the amount that we need. Okay. The rate I'm being paid is 6%, so 0.06, right? 6%. This is semi-annually, which means 2, right? If you don't remember, right, all you have to do is go back up to this little list up here that I made, right? Semi-annually is 2 compounds a year, right? Typically taxes work that way, 2 and 4. Okay, so number of compounds is 2, and the time period is 18 years, because that's how old our kid is, right? Or going to be at that point, 18 years later. Okay, and these never work out nicely. So let's do an approximation and put a $sign, okay? Okay, so let's shrink that down a little bit so we can have some room. Shove that over and go to our spreadsheet. Okay, so we're going to do P equals, and shift that to the right. Okay, so if we have a denominator and numerator, so we have $40,000, which is what we want, right? So we have 40,000, so equals, to calculate it, 40,000 divided by, and then we have all this stuff on the bottom, correct? That's going to take a lot of work there. So I have a couple choices here. So parentheses 1 plus 0.06 divided by 2. Right, and you can do the power of, let's see, that's 2 times 18, that's 36. That should work, right? That's one way to do it, okay? But that's assuming that I've calculated the 2 times the 18, right? See the 2 times the 18 there? I believe if you do it the other way, it should be fine too. 2 times 18. Yes, it works either way, and you can make it bigger to get more decimals than that. Well, I guess it actually stops. I think we can add more decimals here if I go to home and I just, where's the number thing here? Yeah, I can add, well, I guess it actually, no, yeah, I can add more decimals with these things right here. It goes less or more, right? Okay, so that's what we'll take for our answer. So $13,801, and we'll say 30 cents because you typically have to round up, you know what I'm saying? Well, for now, we'll say 2970 ... So typically you have to invest the extra penny, so that you round it up to 30 cents because it always works in the bank's favor, you know? Okay, so that's orange. Okay, so long story short, what did we do? We took the compound interest formula. We solved for P, so that allows us to figure out how much we need to invest to get a certain amount later in future value. So my present value should be $13,801.30, right? Which means in the future I will have $40,000.